Okay, recording. Perfect. So let's talk about post-processing effects. That's why the class I did yesterday was, and we discussed all the kind of effects you can do. There's lots of them. Remember that, well, you work in graphics as long as you have an image, you can do any crazy things, but we're going to focus on the ones that we are more interested on. Which are the simple ones, how to construct a simple pipeline for processing effects. And I will discuss maybe a couple of effects that I think are interesting. Maybe I do a blur, and maybe I do the worst blur possible, because on the slides there's a better one that I want you to code. But I'm going to show you the worst one, and also I'm going to code the anti-aliasing using the motion blur approach, so you have a reference to work on that. Okay, so this being said, let's go to check what we have from the last time. So this is our render, and I think last thing we did was decals. So here we still have this part for the decal. Yes, because I didn't set up any file name here, so we were using this the other day to have here a decal, and then we were rotating it here to have it. Okay, but anyway, forget about the decal because we did it very fast. So today we want to apply some post-processing effects to this image, okay? Deciding from the very most simple ones to something more interesting. So for now, let me go to the decals. Decal rendering, and if there is no decal, I don't want to render anything. So in this case, if the decal file name size is equal to 0, I'm going to skip this decal because it doesn't make any sense. And otherwise, I don't have to put this because this makes sense. And I already have this texture. No, yes, good. Yeah. Okay. So during the rendering of my frame, usually we have passed so many steps, and we construct the G buffers, we render inside the G buffers of the whole scene. Here we were doing all the decals thingy, and final the SSAO, volumetric, all things. And here is the last step where we compute all the illumination. So at the end of this buffer here contains every single pixel of the final image. And I was saying that the last step usually is to apply a tone mapper, but what we want to do is apply a bunch of steps here, okay? And I can put it here, but I'm going to put it in another function, like something like, I don't know, void render PostFX. And the reason why I'm going to do this is because I'm going to need to color buffer, and probably I'm going to need also the depth buffer. I'm putting inside another function because I want to use the same function for rendering PostFX when we render in forward or deferred usually. Although in the ferret, yeah, I have the depth buffer too, so I can use the same function for forward and deferred, so I don't have to have the same code again. Okay, so let's go and create this function, and because it's going to be called by both of them, maybe I can put it here for now. Okay. So here, this function is going to be called when you have finalized the whole render, and you want just to show it to on the screen. So let's go render PostFX and call it on the render deferred, probably here at the end. Yeah, here. So this, when we want to render the final image, we're going to call this function. And we need to pass the color buffer, the image that contains everything. In this case, the color buffer is here. And we also need to pass the depth buffer, which is also here. Okay, and we understand that all this code should be done inside this function. So for now, if we want, we can start putting it here. And as far as I understand, we haven't destroyed anything. Okay, so we have a shader, we enable it, we pass some variables, and instead of using this, we're going to use color buffer to be pushed. Okay, so this should be exactly the same, but a little bit more clear that the tone mapper is one kind of post-processing effect. and we want to do it separately. Okay, so, and I wasn't calling this function on the render forward. Maybe I should separate the render forward to call also this function, because I don't know why I wasn't using it. But you can see here that if I render in forward, I don't have a way to control the forward or a render mode here. The third is calling this function now. Okay, I know it's different, the forward and the image engine, because well, I did it very fast, but in yours it should be supposed to be the same. Okay, indeed, I'm going to put that by default is going to use the deferred renderer image engine, because I want to be sure. Yeah, it's also deferred by default. Okay, so I shouldn't have any problem. But on the show UI, by the way, here, yeah, here I forgot to put 0, and probably that was why I was doing something weird. Yes, let's see if it goes now, because it was strange that it was not showing the deferred by default. I thought there was that mistake there. Let's see. Okay, so we have it, the third render, which looks like this. We can go to the forward render. That looks slightly different. There is no shadows on the third now. I don't know why. Probably I missed something the other day when I was, oh, there's no shadows for the sky, but there's shadows for this one. Yeah, that was something weird that we discovered the other day. I don't understand why. Well, anyway, I will investigate, but this is not the topic of today. The topic of today is how can I make this image look more interesting. So let's go back to our render PostFX. So what is clear, as I said today, is that if we want to apply several algorithms, it would be nice that that we can not use a lot of memory. So the best solution to approach this problem is usually to create two different FBOs. So let's call, for instance, this first one PostFX FBO, PostFX A FBO, on PostFX B FBO. So we are going to have two, and we're going to keep doing ping pong between them. Okay, so we're going to render something on the first, and then the output on the B, and the output on the B on the A, and as many steps as we want to do for our algorithm. For instance, if we want to blur, then we can do that. So obviously we need to have this created. So if this is not created, we're going to have to create a new FBO, which is going to have an image. Yeah, an FBO. We're going to create both of them at the same time, and we're going to create here the width and the height is going to be the size of the color buffer. Because if we're going to apply any effect, it makes sense that the effect has to have the same size as the screen. Number of textures, 1, because an effect only needs one texture. I mean, we don't have many layers. GRGB, because we don't care about the alpha. I mean, it's a post-processing effect that is going to be displayed on the screen. It's going to have alpha. And finally, how much precision. I'm going to use half float, okay, because I want to keep the HDR, okay. Remember that if we didn't put half float, we will lose all the information of HDR, and for some algorithms, they make sense to have it. So if we do this, we have now both textures, and I'm going to use a variable here. Let's call it current FBO, which is the one that's supposed to be, because the idea is we're going to do swapping. Yeah, well, anyway, I will do swapping, which is easier. Swapping means that I want to use always the A and as the input, and do store something on B, and then when B contains the latest version, that is image, I'm going to swap both pointers. So B is going to be A and A is going to be B. So that way I know that A always contains the input and B contains the output. Indeed, maybe I can call the names like this. I think it will be better. I didn't do like this in last year, but something like this. So there's going to be one call it in, and there's going to be one call it out. And we're going to now apply lots of effects. So the question is which effects? So we're going to have a lot of shaders to do this. So obviously we're going to start coding here some shaders, and they are all going to be quad because FX, I don't know, color. I just color correction. I don't know. Let's add a color correction to the first one. Do something with the colors, okay? So for color correction, we're going to go with some very simple quad render shader. I don't know if we have something here. Maybe this one. Anyway, I'm going to use this one because it's very simple as a boilerplate. And I'm going to have a texture here. And some UV, some frag color, blah, blah, blah. And usually what you're going to end up doing is you're going to have a vector for color that is going to always, usually you're going to read from the texture using the UVs provided by the quad, and you're going to do something on this color. Imagine that I want to increase the brightness, so maybe I can have a uniform float brightness. Okay, and I'm going to say that I want to multiply the color by brightness. And that's it. I mean, I don't have to do anything. Keep in mind that by doing this, I'm modifying also the alpha, but because I'm not going to use the alpha for anything, it's okay. Okay, although it would be more clean to do something like this, so you don't multiply the brightness by the alpha, but even though it doesn't matter because we're not using alpha for anything. Okay, so we have a color correction shader here, and so let's go to our engine now, and we are going to use this thing. Okay, so the first thing we need is that the texture has to be inside here, but the texture now is here, it's not here. Remember that the idea is that I want to have a function that applies a shader from this one texture to this texture, okay? But currently this one is empty, so I need to copy this one. So maybe I can copy it very easily if I bind this one, okay? And always when I bind it, I put on bind to be sure. And I just take the color buffer and to viewport. That's it. I mean, remember that this will copy, it will, to viewport is going to render a full screen quad. And because this is going to be on this one, at the end is going to have the image here. And I could have done something more like semantic or simple, like saying color buffer, copy to, remember I have this function, to PostFX in FBO, color texture 0. I mean, this will be the same, but this is slower because this function inside copy to, it has to construct a new FBO and assign the FBO to this one, and assigning textures to FBOs is very slow, and we want to try to avoid assigning textures to FBOs. First, you create the FBO with a texture assigned. This is slow doing this, but you only have to do it once when the application starts. And from now on, I will just keep using these textures here. So this is way faster to use this one now. Okay, so now we have, in this texture, we have the final image. And so the image that we want to apply an FX. So let's apply this very simple FX I was showing you before. Maybe I can do it like here. So how we're going to do this? First, we're going to bind the output. Okay, we're going to bind the output. We're going to take the shader. Okay, and we're going to have to pass here some parameters, but mostly what I care is this brightness. I don't know. Let's call it brightness, which is a variable I haven't set up anywhere, but I'm going to set it up here with all the junk variables I have here. And obviously for every variable I set up here, I have first to define it somewhere here. So, and more important, I want to have a UI because I want to be able to play with this variable. So okay, so now I have a way to control the brightness. And when I call this function, this here, control color, color correction, is going to bind the shader, is going to, bind the output FBO, take the shader, enable the shader, pass some variables, which I forgot to pass also the texture. this is, in this case, which is the texture I should be putting here? I'm always going to take the texture of the in. Color texture 0 and put it in number 0. Okay, and it's going to, well, I don't have to do this sec texture here if I don't want to, because this color buffer to viewport is going, by default, is going to do it. You can see here it's going to set uniform this texture to 0, and it's also going to disable the text, cool face, all the things. So if I wanted to skip one line, I can remove this line if I want to, because it's not being to change, because it's already done here on this function to viewport. Okay, so at the end of this, PostFX out color texture will contain the output of this algorithm. Okay. But I want that always the latest version of the image is not in the out, is in the in. So after taking the in, so let's paint a little bit. So we had a buffer and we have two FBOs. Okay, remember this is in, and this one it's oops, damn it, and this one here is out. So the first thing we have done is put the image here. Okay, so now we have applied an algorithm and we have it here. But I want that always, when I have to start an algorithm, always it starts using the in one. But now the in doesn't have the latest version. The latest version is out. So what I'm going to do is I'm going to swap these two pointers. Okay, there's different ways to do that. In C++, you can do just the function swap. And if you pass here two pointers or two variables, whatever they are to, this is the function that swaps the variables, puts this here and this here. Okay, cool. So if I do this, I know that the in contains again the latest version, because now this one has become in and this has become out. So always in contains the latest version. So if at the end I want to apply the tone mapper and render to the screen, which is the latest step, the only thing I have to do is take from here the color textures 0 and render it to the screen. Okay, so let's try to see if this works. Okay, I'm applying a shader and storing between different FBOs, and I did something wrong because shader is already initialized, so I can remove this. Let's see. So I have two steps now on my post-processing. I have the step to apply color correction and the step to apply tone mapper. Okay. So if I execute, well, I have 3 steps if I count also the copy of the whole buffer. You can skip this one if you just have an if in the first one that uses the other texture. But anyway, so here I have my variable, call it brightness. If I touch it, you can see I can control the brightness. Okay. And obviously, I can control also the gamma of the tone mapper. Okay, so I have already 2 steps. If you are a little bit smart, you probably will see that I can just put these 2 things together. I don't need 2 steps, because the tone mapper here, if I go to the shader of the tone mapper, here, remember, I have here the tone mapper. What is it here? I could just, when I read the color of the texture, here, multiply here by brightness. So if I multiply the color by brightness, I save having to do a full screen quad, binding new FBOs, etc. That's why I say that sometimes it's good to put a lot of effects bundled together in the same shader. That means that you can save a lot of steps on your post-processing layer, and usually post-processing layers tend to have a lot of steps, so it's better to try to pack them if you can. But for now, because I want to show you different ideas and different concepts, I'm going to keep going with this. Okay, cool. So another effect, I'm going to try to blur the image, because I think it could be interesting to see how to blur an image. Okay, and I'm going to add the blur on top of it, what we call bloom. Okay, which is not glow. Don't make it wrong, because glow is what I asked you to do for the final assignment, and glow requires to do more steps. You have to read the slides to see how it's done. Maybe I show you something, but making a blur is very easy. So let's try to make a blur shader, because it's always good to have a blur shader. So let's call it blur, FX blur, and blur. Okay, so how does, why is not finding this one? Okay, it says this file doesn't contain any color correction. What? I just typed it out. 1 second ago? Visual Studio. Here. Oh, yeah, look, it's here. Cool. And so it was searching on the file and it wasn't finding it. Okay. So we say what's going to be called blur. And remember that we have the code of the blur on the slides. I put it here because it's always nice to have a template for blurring, which is very simple shader, as you can see here. I'm going to have to modify a little bit some lines of code, I think, because it's using the old GL frag color, but I don't want to use the old version, and it's also using, yeah, I think I can remove this one, and that's it. Yeah, I already have the texture there. So, but I need these two things, offset and intensity, because you can see that offset and intensity is used here. Also, I don't want to use the old version. Remember, the texture 2D is in the old version of shaders. In the new version, you just put texture and that's it. And that's it. I mean, I'm going to start with black. I'm going to add all these ones here. And at the end, I'm going to do the average by dividing by the sum. Yes, no, intensity. I like to put more like this. So this is the end color multiplied by some scalar. Then putting the scalar and then the color looks weird to me. And that's it. That's it. Remember that this blur, by the way, is one directional. Like it's one dimensional. Sorry, that means it's going to blur only in one direction. Not going to blur in two. So if we want to have a proper blur, we have to do twice. Blur horizontally, and the output has to blur it vertically. So let's do that. We need these two variables. So maybe we can have here, we can copy this code probably. No, I don't want to. I will copy this one. I think it looks better. Okay, so shader blur. We enable the shader. And we need to pass two parameters to our shader. First is an intensity. For now, I don't care too much, so I'm going to pass just regular intensity. But the important one is the offset. Remember that the offset is every time I want to go to the next pixel, how many I have to move to the right or to the left. Okay, so this is the inverse of the resolution of the image. So in this case, if I'm going to do it horizontally, this is going to be a vector 2, where horizontally I'm going to move 1 divided by the texture size. In this case, I usually like to put color buffer width as a variable here in width, and the same for the height, because I'm probably going to need to use these variables a lot. I need to put forward there, so I don't have to keep typing all the time these things. So that means that now if I want to specify here the inverse of the width, I can say this. And vertically, we are not going to move, so we're going to do an horizontal blur, okay? So if I do an horizontal blur, it's going to move only in X, not in Y, and this is going to be the offset, so vector 2, and I'm going to apply this shader, and at the end, I'm going to swap, okay? And if I do this now, everything goes well. It crashes because I defined the shader twice. Maybe I should just put the shader outside here. So I'm going to put it like here. Shader equal null point. So I don't have to have the same problem again if I copy code. Okay. And if everything goes well, we should see something a little bit blurred horizontally, which is not so much. I mean, it will look blurred. Yeah, I don't know if you can see it, but it looks blurred. A little bit, a very slight blur, but it looks blurred, okay? But it's very, very subtle, and it's also horizontal. You can see a little bit here. So it's not a regular Gaussian blur, it's only horizontal blur, okay? But if we want to do it well, I don't have to do the swap. I can just, when I finish doing this, I switch to the in again. And I do the same, but now instead of using, no, this is wrong. I shouldn't be using the color buffer here. I should be always using the texture here, color texture 0. Okay, this is important because otherwise I'm not using the proper texture. It was working because they were the same, but be careful. I copied from the sorry, this is the color correction. What am I doing? Damn it, I'm destroying my code. No, sorry, here, this is the bloom, and this one is, as I said, this is wrong. This should be the in color texture 0. So this is the input. So at the end of this one, the in contains the new image. So not the out, sorry, the in. Okay, so we are going to use, this is the input texture that we want to apply the effect. Okay, so now at the end of this pass, we have on the in, we have, because we have swapped it, we have on the in the horizontal blur. So if we copy this code again here, indeed, I can do something more simple, which is I can do bind it here, render and unbind, swap, and do again the same, but with a vertical. So instead of this, it's going to be a vertical blur. So we pass the offset as a vertical vector, not as a horizontal vector. So when we apply the same blur, it's going to blur. And because we are using the in again, so it's going to apply to the two blurs to the same image. So at the end, it should look good. Okay. And if I execute this, I should see some sort of blur. Okay, this blur now, it's only using 5 pixels kernel. I think 4 pixels to the left, 4 pixels to the right. That's 9 pixels, 9 by 9 kernel, which is not much. That's why you won't see here the blur. I mean, you can see the blur, but it's still very subtle. It's hard to see. Let me see. I think I'm not sure if it's right. I have the impression that it's not right, but maybe it's just an impression. Just let me be sure that I didn't do anything wrong. So this is going to render to the out using the in. It's going to render the image and then unbind. It's going to swap them, and this is going to also bind the out. It's going in. Yeah, I think it's right. I don't know. It feels like it wasn't. It didn't look right. But I want to say this because if you go here now and you do an iteration, like, I don't know, int e equals 0 equals 5, you repeat this process for 5 times, you're going to be blurring the image horizontal, vertically, and then you start again and again. So you're going to end up applying a bigger kernel because you're blurring a blurred image. And if you do it 5 times, then this is going to be 10 draw calls, which are not cheap, but still is going to, you're going to see now that it looks way more blurred, the image. Still, I don't think there's something wrong. Maybe it's my impression. I think that I have the impression that the height is wrong. Wait 1 second. Height is color buffer height. This is right. And offset is 1 divided by width, and offset 1 divided by height. Why do I have the impression that it's blurring a lot horizontally, not vertically? I don't know why. This is weird impression. Maybe it's not doing the swap. This function swap is not working well. Maybe I have to do it manually. Yeah, I'm pretty sure it's blurring horizontally, not vertically. Because you can see how it is stretching this horizontally, not vertically. So it's not doing the second one properly. Let me go to the shader to be sure I'm not doing something wrong. I'm using U offset, and U offset is a vector 2. So if it has vertical, it's going to apply it vertically. So yeah, this is perfectly well. So my only guess is that the swap is not being applied properly. I'm going to make a test. Instead of swapping, I'm going to do something more simple, which is on the second one, I'm going to take the in and here the out. Okay, so now you can see what I'm doing here. First I'm going to take the input image, I'm going to start it in the out, but then I'm going to bind the input FBO again, the original one, and I'm going to use the output of the other one as the texture. So it's like doing this. It's like you have done the swap twice, but if you do the swap twice, it's like not doing any swap. So I just to be sure that the swap is not the one that is doing something weird on my render. No, it's happening again. Maybe I'm stretching the image with grid. Okay. Super weird. It's like the second time this set uniform is passing the same uniform as the previous one. Hello. To viewport doesn't. It enables the shader again, but it's okay because I'm not doing anything. You enable it again, it's okay. And the texture is texture. Okay. Well, I have some time. I will investigate. Just to test it, I want to be sure that width and height are different values, because maybe in some of the steps I put the width and the height the same, although it shouldn't be the same, and that will explain why when I do the blur horizontally is there's some sort of offset vertically. Or what I can do also is just to apply the vertical one all the time to be sure that it's not that one. So here width is 124 and height is, yeah, it has a proper size. So I'm going here and I'm applying the effect, and when I go here, something weird happened. Something crashed. If something crashes, because probably some of the pointer is wrong. Oh, I know what it is. Okay, this happens to try to make the code much more cleaner. So what I do here, I enable the shader, and I do pass the property to the uniform. Okay, but the problem is, what does this function inside? This function inside does this. It's disabling the shader, and because the shader is disabled, when I call this function, this shader is null. So I mean, it's not enabled, and when you try to set the uniform to a disabled shader, it doesn't do it. So just for not wanting to put this line again, it was crashing. This will look better. Instead of using this function to viewport, I can do something more like clean, which is I can go to the mesh, get quad. This is a function that gives you the full screen quad, and do the render and GL triangles. Something like this. Okay. It's more or less the same, but I have to set up the texture now. So I'm going to put here set uniform U texture, and in this case the texture is going to be this one on 0. And I want to be sure here, when you start the post-processing layer, it's always good to disable anything, but I'm not going to do it because this function to viewport already disables everything. You can see here that if you do to viewport, I disable the test and curve face. I don't disable blending. I'm going to disable blending because otherwise that could lead to strange situations. Just to be sure. And if I do this, also left test. Okay, so what I have done now is I enable the shader, I pass this information to the shader, I bind this, which this function doesn't modify any shader, I pass the texture, and this is for the out, so I pass the in texture and the slot 0, and I render a full screen quad. And then I unbind this one, and I'm going to do the same again in here, and I can do here the swap. So it was going to look better than the trick I was doing before, which is I always put the out one, and I'm going to take the in as the texture. Yeah. Okay, so this is a little bit more clean because you can see every step. Enable the shader, pass the offsets. I can also put it here if I want to. I think it will be better even to put it outside. So I don't have this enable the shader because I never disable in the shader. Any of these, none of these functions disable shaders. So I can do this. And instead of just doing to viewport, I just get a full screen quad. This function gives you a full screen quad and render on the screen. Okay. And now you will see that this looks way more blurred, because as I said, I wasn't applying passing the offset vertically because the shader wasn't enabled, and because of that I was applying the same offset vertically horizontally all the time, so that's why it didn't look like a regular blur. Oh, it's in the book. Oh, duh. Okay, now you can see this is a proper blur, super blurred. Okay, you can see it's perfectly round because it's a regular blur. Cool. 1 second, I wanted to change something. Yes, please. Okay. But as I said yesterday, if you're going to apply a blur 10 times, you're wasting a lot of resources because you're reading the neighbor pixels, and those neighbor pixels are probably already, like, they don't have too much information. So if you want to apply this algorithm well, I usually recommend that you have, you do something like this. Power, so initially is power of 1, and this is going to be equal to power. For you who don't understand this, this is a bit shift in C++, well, in many languages. Bit shift means I want to take the number here and take all the bits and push them to the left, one position. And I don't know if any of you know what this means, but when you take all the bits of an integer number and you push them one to the left, it's like multiplying by 2. So the first team is going to be 1, then 2, then 4, then 8, then 16. And why I'm doing this power thingy, is because I want to be sure that every time I want that when I apply a blur, the kernel is going to keep growing. Okay. So the first time, it has to be a float. Sorry. There's no function to multiply by integers on my framework. Okay. So understand why I'm doing this. I have a function that could be very noisy. Okay. So if I do a blur, the function is going to be way smoother. Okay. But if I do a blur again, it's going to smooth a little bit, but just a little, because these values are very, very smooth. The trick is the second time, instead of taking this and this and this and this, because these values are going to be very, very similar to the first one, you just skip one of the values because you're doing a blur. And indeed, you don't have to be like in this way I'm just skipping 1 pixel, then 2, then 4. But even though you can go greater, you can be like 1, 3, 9. Like if instead of 1, I do, I think it would be also look nice. But just so you see the difference, if I do this, you will see how the blur looks way bigger. Like I have a huge kernel. Indeed, it's going to be a huge kernel because this is 10 times, so it's going to be totally blurred. Yeah, I won't be able to see anything. But just as an example, that if you use intelligently this convolution, yes, as I said, you're not going to see anything because this is super big. Only doing 4 passes. 4 passes, and that means 1 elevated to 4, so it's 1, 2, 4, 8. And because 8 multiplied by 5, which is the size, it's going to be like, you can see, it's a huge blur, okay? And this is good when you want to do blurs, that you be able to make huge blurs very efficiently. It's always a good idea. Okay, so now I have this blurred image, and I would love to take this image and add it to the original image. But the problem is that the original image that I came from here, I lost it. Okay, that's one of the problems when you apply ping pong. Which you have an image here and you do here, here, here. You keep processing, but in this case, we should have saved this texture outside and then use this texture now to mix it. You want to mix the original image with this image. What is the image with where that enters this algorithm? I could mix it with this one, like the color buffer, the original image, but then I wouldn't have the brightness that I applied here. So maybe it makes sense that I have another one. Let's call it temp. Okay. because there's going to be moments but maybe I want to keep the original image, okay, before applying a blur. And because I am applying a blur using the two buffers, I may want to store this image. So in this case, before I start applying the blur, I'm going to say, hey, can you take this binded and I want to copy that image, so as I was doing before, something like this. Okay, save image. So I'm going to enable this temp FBO, take the input and store it here. Okay. If I do this, that means if in any moment I take the color texture from this FBO, it's whatever image I saved. And why I'm going to do this is because now that I have on this here, I want to apply the combination of this blurred image with the original image. So in this case, I go with a new shader, like let's call it combine, or just to put a mix or something like that. I think I call it mix usually. Where you have two images. This is going to be a very simple one. I think I can use this one because it's a super simple one. You have texture A and texture B, and only thing you're going to do is mix it. Mix value, but I don't care. So I'm going to take this color B from the other texture, and I don't know. I mean, there's different ways that you can do this, but what I'm going to do is that the output is going to be color plus color B. That you can do this also using blending, if you think about. This is very easy to do using blending. Indeed, I could have used blending if I wanted. Let me show you how you can do this with blending. So when I finish, yeah. So at the end of this blurring, this the ink will contain the image. Okay, so I can do this. I can bind this FBO, the one that contains the blurred image, and I'm going to enable here the GL enable def blend. Okay, and I'm going to use an additive function of blending. So in this case, I can say GL source alpha and GL 1 minus, no, I'm going to do GL1 because I want to add them. I want to add the one image to the other image. So this one is going to be the alpha of this one and the other one as it is. So if I do this and now I draw this, the one I saved before, the temp, okay, that contains the original image without blurring, this one here, to viewport, okay, what's going to happen? So we have an image here after applying the brightness. We're going to save this image on this temp because we're going to make a clone. So we have it here on this temp FBO. And then we're going to blur a lot the image, the original image. And at the end, we're going to bind the input. And we're going to only draw the original image on top of that. And we're going to use this blending, which is additive. I'm going to disable it at the end to be sure I'm not messing around with next renders. So at the end, this SVX in FBO will contain the original blurred image plus the temp image that is added on top of it. So let's check if it looks nice. And you can see it now, okay? So you can see how you have both things. You have the blurred one and the original unblurred one. So this is what it's called the bloom, okay? Which makes sense when you want to make something more oniric, okay? So that's one of the things that you can do if you want to have something that looks more like a nice fantasy escape. Okay. So now you have an example how you can apply blurs if you want to, and this is an example. And the algorithm I'm asking you to code, the glow that appears on the slides, is not similar to this one. It has some differences. Okay. The one I'm going to show you. Let me show you here on the slide about that nice glow. No, this one, no. Yeah, this tutorial here. It's called bloom here, but it's not bloom, okay? So what it does here, this one, is it's going first to downsample. So what it's going to do, this algorithm, so you understand how it works, is you have the image, okay, the original image. It's going to create an image that is half the size, and it's going to copy this image here doing downsample. How do you do downsample? You make a shader that for every pixel is going to go to the original image, and it's going to take the neighbors, and it's going to do an average, okay? So for every pixel here, it will be like the average of these pixels. It's similar to computing the min maps if you think about, okay? So this pixel here will be an average of these pixels. But then you repeat the process with a smaller one. And then you repeat the process with a smaller one until you reach one of an image that has one of the dimensions is 1 pixel, okay? So this way you will have somehow that the information here will be like if there was a very, very bright pixel here, imagine that this pixel was super bright. This will mean that this pixel will be also bright, but a little bit less because it's an average, and here will be a little bit less and a little bit less, but still it will be super bright, okay? And now you do the opposite. You take this image here and you add it, you upscale it to this image, and then you scale it to this image, and then you upscale it to this image, and you scale it to this image. And when you do that, what is going to happen is this pixel that was super bright, when you downscale it, it ended up being a little bit here, a little bit on the area here, a little bit on this area, a little bit on this area. So every time you add it together, it's going to spread all around in all, because every image will apply a little bit a little distance. Okay, so it's just you downscale and then you upscale. Okay, it's as simple as that. And this is the glow that I showed you the other day that looks super beautiful, and it's kind of easy to do. So here you have an explanation how you have to downsample the image, and you have all the steps. And here you have how he keeps using the same destination and source, something similar to what I'm done now. And then you do the opposite, you do the upscaling. But what is important is when you upscale, you have to accumulate, you have to add. So it's going to be this image plus this image plus this image plus this image plus this image at the end. Okay, that's the important thing. You have to do this upscaling. And if you do it right, you get this bloom that is super big and it's very cheap to compute. Okay, I don't know if there's an image here. Here maybe you can see it. So you can see how it downscales, and now it keeps adding every downscale version. Well, he doesn't add them, he just shows it here. But now if you add them, as I was saying before, you get this one, okay? So you can see how you add all these blurs that you have, and it looks super, super nice. Okay, so this is one of the algorithms that it's very easy to implement. Here there's more tricks that you don't have to, like if you want to add some extra things, but the simple approach is the good one. Okay, so now we have here our bloom. And because I still have time, I want to apply another algorithm that I didn't apply, which is the one where you apply motion blur to the image based on the previous frame. Okay, I think this is an interesting one, motion blur. Okay, so what's the idea here? The idea to do this algorithm is that we're going to see for every pixel where was this pixel on the previous frame, and we're going to apply like an average of all the pixels between what this is pixel now and what it was before. But this one, motion blur, you shouldn't apply it after the bloom, because it's going to destroy the bloom, because it's going to apply this average to the bloom also, which doesn't make any sense. So what I'm going to do is I'm going to apply it right before, after like when I have the color correction here. Okay, so how is it going to work? I'm going to make the shader first, maybe, because it's going to be easy. Because the mix I'm not using, I'm going to use this mix one again, because I don't want to have to call that now. So let's call it a motion blur. Okay, so you're going to receive one image. You're not going to receive the previous frame. Okay, in this blur, you only need one image. Okay, but I'm going to need to know where was this pixel first. What's the wall position of this pixel? How do I know the wall position of this pixel? I need to have the depth buffer. Okay, so I'm going to need to have the sampler to the U depth texture, because I need to reconstruct the wall position of this pixel. And I'm going to need to, obviously, if I want to reconstruct it, I'm going to need also the VP of this image. And I'm going to need, yeah. Let me think if I can make it simpler. Nah, erase. Okay, so then I can use the same approach I have done usually many times, which is doing this to reconstruct from a coordinate the wall position. Okay, so I'm going to put it here. So I'm going to take the UE res and the inverse of the resolution. I'm going to take the depth from the depth texture. I'm going to, if it's, forget if it's 1 for now. And I'm going to multiply by the inverse view projection, EVP, sorry, no VP, EVP. And then I will have the wall position of this pixel. So this is going to be, if you think about this, a little bit of a screen space effect, because I'm using the wall position, not the color of the pixel itself. Just a small comment that I think I forgot to mention. If you want to do motion blur, and the idea is that when you render an image, like the camera, for instance, is here, and I see this image, okay, then if the camera moves, like here, and I see another image, okay, the proper way to do blur should be that from this moment on time, t, to this moment on time where the camera is here, sorry, this was t, and here is t1, okay, we can understand that this camera has been traveling through all the points in the middle, like the infinite points in the middle. And if we want to do motion blur properly, the good approach should be to take the camera here and here, render the whole frame, and do the average. Okay, some 3D softwares, when it's not real time, when they have a lot of time, they do this. They render all the in between frames, so you get a proper motion blur. The more frames, the more beautiful is going to look the motion blur. Okay, but this approach I'm going to follow, it's kind of a hackish, because it's more like I have this frame, and using only this frame, I'm going to try to come up with some kind of directional blur on every pixel that a little bit looks like the blur from if I had rendered all the middle ones. Okay, so it's not perfect, it has a lot of artifacts, but it's way cheaper because I don't have to render the scene hundreds of times. Okay, so if I want to do this, I need to have the VP, erase, and depth texture. Okay, so let's go. This is called the motion blur effects. So let's go to my function here, and let's apply our pipeline here. So motion blur. Okay, and I'm going to pass here all the EVP. Yeah, these ones. 1 second, motion, yeah. Motion blur here, sorry. No, color correction, no, what? Why we modify this one? You never realize about this. When I do something wrong, I was expecting you to say, hey, Javi, you do it wrong place. This one, this is the motion blur. I was modifying the color correction. So in this case, I need to have here the width and the height. Okay, and I need a camera. I didn't pass the camera here, and it's always good to have the camera. When I call the function render PostFX, because I may need to know things about the camera now. So let's go here and say that in my response, this function, I'm going to pass also the camera. I can take it from the current camera, but I prefer that I pass it because I know which camera I'm going to pass unless, because if I can take the current, maybe the current is an old one I enabled to compute the Radiance Prof or something, and just to be sure I'm not mistaking anything, I prefer to do it this way. So PostFX here, I'm going to pass the camera. Cool. So do the motion blur, I pass the inverse of the resolution, I pass the EVP of my camera, and I pass the depth texture. But remember that besides knowing the wall coordinate of this pixel, the algorithm relies on when I have a point, I want to know the wall position of this pixel, and I want to know the wall position of this pixel also, sorry, what I'm going to do is I want to multiply this world position by the other view camera to know in which position was this point before. Okay, so I need to have the VP of the previous time, so of t minus 1. So to do that, how can I do that? I need to pass a second VP, not a EVP, but a view projection of the old camera. Let's say pref view projection. Okay, this function pref view projection is going to be, I can put it here as matrix 4 preview projection. Initially it's going to be an identity, but after this algorithm I'm going to take the view projection of my camera and I'm going to store it. Oops. So the first frame is going to be wrong. It's okay, it's just one frame, it's not a big deal. But next frame, when I go to preview projection, it's going to take the one I used on the previous frame, because at the end of this function, it's going to copy the view projection that I have now on this pref. So the next frame, when I go back again, is going to have here the previous one, okay? So let's call it pref VP. And that's more or less it. It's everything I know I need. So what I'm going to do now in my shader, I need to have also this matrix. So I have the world position. What I'm going to do now is I'm going to say, hey, where was this pref screen pose? So the pref screen pose, where was this pixel on the previous frame? Is easy. You just have to multiply the previous VP by the world position. Okay, world position. Remember that we put one on the and this way I have a vector 4, which is the previous world position on screen space. And remember that usually we do this, always divide this by the W, because when you multiply by a projection matrix, it goes to homogeneous space, and when you divide by W, it goes back to clip space. So now this position goes from -1 to 1. Remember that our UV goes from 0 to 1. So I'm going to convert this from 0 to 1. I'm going to say that I only care about X and Y. So I'm going to say that X and Y now, because it goes from -1 to 1, I want it to be multiplied by 0.5 plus 0.5. Okay, this way, this value that goes from -1 to 1 is going to go from 0 to 1. Okay, and this is way better because that means that I know the coordinate of the screen where this pixel was on the previous frame. Okay, so now I know where is now the UV and where it was before. Indeed, I can do something like this, pref UV, which looks much better. Okay, so if I know where it is now and what it was before, the only thing I have to do is interpolate between these 2 points. So let's do like, I don't know, 10 steps, 16 steps. I think 16 looks like a nice number. And what I'm going to have here is like a vector 3 color, a vector 4 color. That is going to be initially 0. Okay. And what I'm going to do is I'm going to keep reading the color and adding it here, okay, and at the end I'm going to have to divide this color by 16 because I have used 16 steps, and that should be. But the problem is that this UV has to change every frame. So initially, let's put it here like interpolated UV is going to be an interpolation between where the UV was on of this pixel that we want to compute the motion blur, where it was before, and here we need a factor that goes from 0 to 1 on this. So if it goes from 0 to 16, it's going to be E divided by 16. Because this is not a float, I'm going to put it like a float. Okay? Sorry, this F doesn't have to be here. So think about what I've done. Okay? I have this image here, this pixel. I want to know the motion blur of this pixel. So I want to know where was this pixel before, and I multiplied the world position of this pixel by the previous VP, and it's going to tell me on screen space on the previous frame where it was. So it's going to say, I don't know, this point if the camera has moved a lot. And then what I'm going to do is I'm going to go through all these points like 16 times, and I'm going to find another UV, and I'm going to read again and again and again the texture, and I'm going to accumulate these values. Okay, if I do this 16 times and then divide by 16, it's going to be the average between this point and this point. Okay, super simple. I don't think I did anything wrong. Obviously, the more steps is going to look better because you will have more resolution about the. You don't see so much banding, so much artifacts. It's not going to look very well. I have to tell. Wait, this is wrong. What's previous? Ah, yes, mix. No, this is good. UV, yes, UV, preview UV, and this is the mix. Yeah. Seeing the other chat. There's another chat. Sorry, I'm in graphics. Which other chat? There's another chat. Oh. Okay, sorry, I wasn't seeing this one. Thank you, David. Cool. So you say we saw the previous inverse, right? We don't need the previous inverse. We only need the previous VP. Remember why is why we use the inverse? The inverse is for the VP goes from wall space to screen space. Okay. And this is when you use the VP. And if you want to do the opposite, you use the inverse VP. The idea of this algorithm is I want to know, if I know the wall position of this pixel, to know the wall position, I needed the EVP, because I need to have the wall position of this one. But now I need to know the screen position of this pixel here. To know the screen position of this pixel, what I have to do is multiply wall position by a VP, in this case, the previous VP. Okay? So in my screen here, what I have here is the previous VP. I'm uploading the previous VP. No, I'm saving the view projection. I didn't save the previous. And now I multiply the previous VP by the screen position to get it where it is. And now I do the average. And I think that's it. I don't think there's nothing else to do here. Yeah, let's try it. Although this algorithm is, I mean, unless I move the camera a lot, you won't see much difference. Ah, fuck. I'm using color buffer again. I keep copying this block of code here that it doesn't use the input, but it's okay. It won't have the brightness shader, but it's okay. So you can see that if I move very fast, how you have this kind of artifact. Okay, I don't know if you can see it on the screen. And it's funny, I don't know if you can see it. It's funny that because we are applying it before the blur doesn't seem to be applied here. So you don't see the smear, you don't see the blur. I don't know if this is right. 1 second. So as I was saying, this should be here like this. So at least motion blur uses the output of the other one. But then I'm copying this in the in. So I think it's that you can see it, but there's something strange. Like I was expecting that you were going to see the blur, the glow of the lights on the skybox also smeared with the motion blur, but you don't see them. You see them only the points that are very bright, but not the other ones. Which won't be the same if I copy this code, by the way, and I put it after the bloom. Oops. This will be totally different. I want to try to see how it looks like. I have the impression that there's something wrong here, but I don't know what it is, so you can see now, yeah, you don't see those points so much, but also you don't see the blur too much. No, there's something wrong here. There is something, it's also clone def buffer here. Wait, damn it, I copied the code. It doesn't change the fact that it's supposed to be the same. Yeah, I don't. There's something that I was expecting it was going to look different, and I don't know why. So I'm going to put it back again here, because this one is copying the in, and this at the end is swapping in and out, and I'm rendering to this one, as I prefer to put this right before I start rendering. So, I mean, it works, but I was expecting a little bit. I mean, you can see the motion blur, but I was expecting a little bit of difference on the glow. It's like the copied one is not the output of this one, but it is. What I copy here is the in, and the in is the what it contains. Oh, it crashed. Wait a second. It crashed because depth texture buffer. This one is not supposed to be right, but why did it crash? Motion blur. I did something wrong with memory. I'm not using temp. Nope. Maybe I'm not passing the depth buffer. I think maybe the depth buffer I'm passing is wrong or something, and that's because it crashed when I... Yeah, it's crashing because this depth buffer is null. Okay, I did something wrong when I was calling this function. 1 second. Illumination FBO. Oh, yeah, this is wrong. Remember that the illumination FBO, I didn't have a depth texture, because when we create the illumination FBO here, I put that the illumination FBO doesn't have a depth buffer as a texture, because I don't need it, because the G buffers contains the depth buffer. So yeah, I was doing it wrong here. So instead of this, I'm going to use the G buffers FBO that contains a depth texture. In this case, as always, it's good when you do this to avoid this kind of errors, don't waste time, to put something like this, like assert color buffer and depth texture, depth buffer. Okay. This means that if this is null or this is null, it's going to stop the application in this line and say, oops, don't keep going, because even I can put it here on the first line. Okay, this is always good to do, because if you, by any reason, you forgot to pass here something, you control it sooner than just letting your code run and discover later in the middle of some function that something is going wrong. But it's going to look the same. I mean, the cloning thing I did of the def is not going to change anything as far as I know. So it's okay. We have the motion blur. And that's it. I have the impression that the motion blur is being applied before the glow, but the glow is not taken into account. The impression I have is that this bloom is not taking into account the motion blurred image. But it's strange, because it is. I mean, I apply the motion blur and it's here, then I clone it here, and then when I start doing this, I'm taking the first time the texture is the in FBO color texture. So yeah, this is the out, and it's going to take the in. I don't know. I think maybe some like impression I have, maybe it's right and I don't see it properly. I don't know. But anyway, we have coded a couple of effects, and I think I'm going to leave it here. I don't want to code more effects because it's part of you that you try to play around with these shaders and this stack. Most engines, they usually have all these effects instead of just, as I'm doing here, putting them all together in one single function. They make a class, like I don't know, FX, a class where you pass the texture and it's going to process the algorithm and output the texture with the algorithm applied. That way you can have a more clean approach of having all the algorithms, and you can enable, disable them. You can have like an array of all the effects, and then you're going to iterate through every effects on the array and apply it, something like that. But if you want to put them all together, it's okay. So remember, what I asked you to do for the final assignment is that you do the super blur, the one I say here, this one where you downscale and upscale. I think it's a very interesting blur and it looks super nice. If you want to apply the motion blur, it's nice. And also, I would recommend you that you also try to, if you want to try the depth of field, it's even more complicated. I put here a guide where it explains a little bit how to do it. okay, with some ideas and algorithms. If you want to try to see how to do it, it uses the blur, so that's why I wanted to show you the blur. So that's one of the options, or you can search on the internet. There's more explanation about how to do this. And I also recommend you to try to do the loot one. And for the image of the loot, if you search on the internet, as long as the image looks exactly like this, I have here an image that you can use, I think. Oh no, they have removed this image. Damn it. Well, anyway, this image, you search it on the internet, and maybe you can, I will maybe upload these images so you can play around with them. It's very important when you use this image, by the way, that it has not been scaled by any reason, because if you scale any of these images, they won't match the right address of when it has to read for the pixels. So yeah, the one on the framework, there is a loot, but it's not this kind of loot. It's another loot. It's a loot for the PBR. Loots are very common when you have 3D graphics because it's more like having a table. I will probably put these ones on the Alba Global so you can play around with the original one and the manipulated one, and you can take the original one, manipulate it, and see if you can manage to modify the colors, okay? And also, you want to try the chromatic aberration, lens distortion, grain, vignetting, or anyone, that would be cool, okay? There's many more. I just said I only put the simple ones, but you can play around with this and to see what you can manage to do, okay? So I think I'm going to leave it here. I don't want to give you too much stuff, otherwise you get lazy. And just try to put make the scene look beautiful. You can play with the values of every post-processing effects until you reach a point where you see that the effect looks beautiful, and also that enhance the scene as much as possible, okay? So don't put an effect that I mean, if it's hard to see that effect in your code, then it's probably a waste of time, okay? So every time you put an effect, put it in a way that it's easy to spot that the effect is there, okay? And that's it. That's the last programming class that you will have on this GTR course. I will try to keep in touch with you on Discord, and I hope soon I can have all the grades of the previous assignments. And if you have any doubt about the final assignment, let me know, because it's going to be an important part of the final degree that you're going to get on this course, okay? So if no more questions, keep in touch. Remember, you have my email, you have me in Discord, you have my Twitter and everything. So drop me any question that you have, even if at the end of the course, if you still want to keep working on graphics. I'm always happy to discuss this kind of topics with you. Okay, so nothing else. Then I'm going to stop the recording here.